Hello, everyone, and thank you for having me. For over 34 years, my journey in research and experimentation has evolved alongside technology itself, moving from analog methods to advanced AI tools, testing workflows in the real world and in research, and exploring futuristic scenarios from now to 2100. This lifelong pursuit has culminated in what I am presenting today, bio-informed intelligence. This is the necessary integration of synthetic biology, artificial intelligence, and digital construction to create truly climate-responsive urban systems. Today, rather than a standard lecture, I want to engage in a dialogue about reality. And to understand our reality, we must start with the fundamental data of our planet, the biomass. We need to examine the tension between the technosphere we have built and the existing biosphere. When we analyze global biomass distribution, we find a humbling truth. Life on Earth is heavily skewed toward terrestrial producers, the plants, and the vast microscopic realm. The data we are about to review illustrates the hierarchy of life by carbon mass. It highlights a stark paradox that is crucial to our future work: the assertion of human insignificance in terms of sheer weight versus our massive impact on the system.
For 3.8 billion years, nature has been conducting the world's most sophisticated research and development.
Welcome to the deep dive. So today we're looking at something that feels a bit like science fiction, but it's really starting to happen. We're talking about moving architecture way beyond just being green.
Way beyond. We're talking about buildings and cities that are, for all intents and purposes, alive, self-regulating.
Exactly. The term the sources use is bio-informed intelligence. Our mission today is to sort of unpack what that actually means for our future cities.
And it's a shift that's, well, it's an absolute necessity. The environmental pressure from what they call the Anthropocene is immense.
Put that into context for us.
I mean, think about this statistic for a second. Humans, all of us, we make up just 0.01% of the planet's biomass by carbon mass. It's a microscopic fraction.
0.01. That's almost nothing.
It is. And in contrast, plants, this invisible majority, they're over 82%. They drive all the planetary cycles. Our static buildings have just been completely ignoring that biological reality.
So the goal is this semantic reset to create structures with, Climatic tropism.
Right. It means they're not just passive shells anymore. They actively adapt and respond to the environment in real time.
But we've been inspired by nature for decades. How is this bio-informed approach fundamentally different from, say, biomimicry or bionics?
That's the key question, really, and it's an evolutionary progression. We started with the biomimicry, which was mostly aesthetic.
Right, like making a building look like a seashell or a leaf.
Exactly. Then you had bionics, which took it a step further. It was about functional abstraction, codifying the mechanics of biology. Think of a bird's hollow bones leading to lightweight engineering.
Okay, so engineering principles.
Precisely. But bio-informed intelligence is the third stage. It's the total integration of synthetic biology, generative AI, and digital construction to achieve active cognition, active regeneration.
The architect becomes a system orchestrator instead of a master builder.
That's it, exactly. They're managing a living system.
Okay, let's dig into that. The creation engine here is the generative AI. It sounds like it completely flips the traditional design process upside down.
It does. Instead of an architect drawing a shape and then testing it, you give the AI a set of constraints: stress, cost, weight, and it autonomously searches for the most optimal shape.
By running thousands of simulations.
Hundreds of thousands. It's using evolutionary algorithms, and the results are just mathematically superior. The sources show it can cut maximal stress, a key failure point, by up to 81%.
81%. That's a huge saving in material and risk. But how do you build these complex, almost alien-looking shapes the AI comes up with?
Yeah, you can't just hand that blueprint to a standard construction crew. That's where digital construction is essential. We're talking about robotics.
Things like 3D printing with metal.
Yep. Specifically wire arc additive manufacturing, or WAM. That 50-meter 3D printed steel bridge in Duisburg, Germany, is the perfect proof of concept. Shows this is achievable right now.
Okay, so that's the skeleton. What about the living part, the living core from synthetic biology?
This is where it gets really interesting. We're talking about engineered living materials, LVMs. You take a structural scaffold, maybe a hydrogel, and you inoculate it with microorganisms.
Like bacteria?
Like photosynthetic cyanobacteria, yes. They provide the regenerative functions, self-healing cracks, capturing carbon as they grow. That's how a building can become carbon positive.
But managing a living, breathing, healing building.
Mm-hmm.
It sounds infinitely more complex than managing steel and concrete. How does the orchestrator stay in control?
The true power emerges when creation meets operation, a continuous feedback loop where every moment of operation informs the next generation of design.
A traditional building management system just can't handle it. You need what's called an agentic AI, the building's nervous system.
A cognitive digital twin.
Exactly.
Like a biological swarm, these decentralized agents negotiate in real time, creating intelligent behavior greater than any single system.
It uses a whole network of sensors, a sense net, to constantly feed data back into a control loop. It's always adjusting the living systems to changes in temperature, moisture, stress. A true cyber-physical biological system.
The cognitive digital twin becomes a living bridge between worlds, a dynamic replica.
We're entering an era of living architecture. Buildings that adapt, respond.
So wrapping this up, what this means for you is we're seeing this monumental leap from passive buildings to structures that are actively cognitive, regenerative, co-evolving with their environment.
It is a huge leap. But it brings us to one final enormous challenge: the data.
The complexity.
The sheer complexity of managing the interaction between our tiny 0.01% of biomass and that vast living majority. Our classical computers are already getting overwhelmed.
So where do we go from here?
Well, the sources suggest the critical need for next generation infrastructure, for quantum artificial intelligence. The idea is something called pan-computationalism, that nature itself is a massive computation system. And to manage it, we'll need a quantum leap in our own computing power. Something for you to think about as you look at the cities of the future.
As we close, I want to leave you with this final thought on bio-informed intelligence. The future of our urban environments lies in AI data-driven and supported bionics, building cities that don't just house us, but function like living organisms. By developing narrow agentic towards general quantum AI capable of listening to the silent majority of the biomass, we can finally shift our paradigm. We have the opportunity to stop being mere exploiters of finite resources and instead become true stewards of information. Thank you